Hello students, welcome back to Clary Concepts Unleashing Conceptual Learning. Today in this lecture, we will be solving numerical examples of the topic called stability of a floating body. So those of you who have not yet gone through my previous lecture where I discussed about how to determine stability of floating body and what is the numerical formulation or formula for determining the metacentric height, I request you to kindly go through that lecture first and then come back in this lecture. So let us begin. The first example says that a rectangular pontoon is 5 meter long, 3 meter wide and 1.2 meter height. So I have been given one object which is 5 meter long, 3 meter wide and 1.2 meter height. The depth of immersion of the pontoon is 0.8 meter in sea water. So when pontoon is lying on the surface of water, so let's say I have the water, sea water, and this is floating on surface of water. So it is said that the width is 3 meter and the height is 1.2 meter as discussed, and from when you look this from the top, the length of this is around 5 meters. Now it is said that the depth of immersion is 0.8 meters, which means the depth over here is 0.8 meters. If the center of gravity is 0.6 meter above the bottom of the pontoon, that means this is the bottom and if CG is over here, so I could say that the distance between the bottom line and G is what? 0.6 meter. 0.6 meter. Determine the metacentric height. This is what they are asking. What you need to find metacentric height. The density of seawater is 1025 kg per meter cube. So here density is given to you, but many times when water is said, density is not given, then you can assume it to be 1000 kg per meter cube. So density of the fluid, which is seawater, is 1025 kg per meter cube. Now what is the question? The question is to figure out the metacentric height, that is GM. So GM, as per our formulation, what we have discussed, it is I divided by volume of body submerged minus Bg. Now let us figure out all these three values first and then we will find out the final value of GM. So firstly I'll talk about I. What is I? I is the area moment of inertia. Of which area? Of the area of the floating body. When you cut the floating body from the surface of, let's say, sea water, when you cut it down, and then whatever area you see from the top, so this will be the only area because the width is constant throughout. So you will see the same area. Now the area moment of inertia of this area, from which axis? I, as I discussed, should be from minimal value. So let's say, for example, this is your YY and this is your ZZ. So firstly figure out I from YY as well as ZZ, and I am 100% sure you will get minimal value of I from this axis. Why? Let us see. So I is what? I is minimum of IYY and IZZ. So let us find first IYY. What is IYY? So from this axis, the area moment of inertia of this area is what? It is always BD cube by 12. But remember this thing, cube should be taken of the length which is perpendicular to the axis that you are trying to find the I for. So let us say I am trying to find I from this axis. So out of this two length, this and this, which one is perpendicular to this axis? 3 meters. So the cube should be taken of 3 meters. So for IYY it is 5 into 3 cube by 12. So 5 into 3 cube divided by 12. You will get 11.25. Meter raised to 4 is the unit, right? And then IZZ. See, it is but obvious because this length is larger, the cube of this. For IZZ, which length is perpendicular to this axis? 5 meter. So 3 into 5 cube by 12. So 3 into 5 cube will always be larger, which is 31.25. So which out of this two is smaller? 11.25, which is IYY. So I will be equals to IYY, which is equals to 11.25 meter raised to 4. You got this one. Now what is VBS? Volume of body submerged. How do you get volume of body submerged? Very easy. The depth of immersion is given, submersion is given to you 0.8. Okay, this is 3 meter and perpendicular is how much? 5 meter. You see, this is the body from top. This is 5 meter. So 5 meter into 0.8 into 3. So VBS is 5 into 0.8 into 3 meters, which is 12 meter cube. So you got this also. Now BG. G is very clear. Where will be B? B will always be at the center of the submerged volume. Submerged volume is total 8 meter, 0.8 meters in height, right? So the center will be somewhere over here, which is at 0.4. So if I draw the line, B will be over here. But I know the distance between the bottom face and the center is 0.4 meter. So now what is BG? BG will be this distance, which is 0.4 minus 0.6. So BG is 0.4 minus 0.6. I think, sorry, it is said that depth of immersion is 0.8, center of gravity is 0.6 meter. So CG is 0.6, so this 0.4 will be even below than this. Just let me, I have made a mistake in just drawing the points, nothing else, right? Let me just show it to you. Let me draw it one more time for you. Okay, see what is said. 0.6 will be half of this, almost over here. So G is over here. So this is 0.6, 0.6 meter. And where is B? B is half of this, and this is 0.4. Now what is BG? BG is 0.6 minus 0.4. So this is not the correct one, it is 0.6. I made a mistake over here. 0.6 minus 0.4. It happens many a times, right? 0.2 meters. Fine. So now you got this also. Now just put the values in the formula. Your I is 11.25. Volume is 12. BG is 0.2. What is the answer? See, calculating the answer is not that great part. What is great is understanding the answer. So I will get 0.7375 meters. Now see, which means when GM is positive, it means the body is in stable equilibrium. So this floating body is in stable equilibrium, it will stay there. Even if you provide some disturbance, then again the body will return to its original orientation. Clear? Let me check the answer whether this is finally correct or not. 0.7375. Perfect, it is right. Okay, let me solve another example for your better understanding. So I have a next question with me. A solid cylinder of diameter 4 meter has a height of 3 meters. So you have a solid cylinder whose diameter is 4 meter and height of 3 meter. Find the metacentric height of the cylinder when it is floating in water with its axis vertical. So what is given to you? A water and a cylindrical body which is floating on the surface of water, and when you look it from the top, this is circle. So basically this is a cylindrical body. So it's a circular body, and from side when you see, this is the thickness, right? So this is given to you as 3 meter and the diameter is 4 meter. Diameter is 4 and this is 3 meter, right? You have been asked to find out the metacentric height. The specific gravity of cylinder is 0.6. So that means you can say that the density of the cylinder, let's say cylinder, is equals to 0.6 into 1000, which is 600 kg per meter cube. And since it is immersed in water, so I can say density of water is 1000 kg per meter cube. All right. Now I need to find the GM. For GM, what did I do? I need to have GM is equals to I divided by, you can say, volume of body submerged minus BG. Let me find all these three values first. First, talking about the I. For I should be minimum of IYY and IZZ. You see, when you cut this body from the surface of water, the section that you will see from top is circular, and this is your, let's say, YY, and this is your ZZ. For a circular shape, IYY and IZZ, both of them will be equal, and which is equal to pi by 64 d raised to 4. So pi by 64 I hope you are remembering this formula, no? Because I am not here to help you out with the formula. So I hope that you are aware about the formulas of mass area moment of inertia. Then multiply by pi. I think this is around 12.566 meter raised to 4. Let me just check it once again so that I am sure that I have made a perfect calculations. Alright. Now, so I you got as 12.566 meter raised to 4. You got this one. Now, what is volume of body submerged? So, for volume of body submerged, you need to know this height. Sorry, you need to know this depth till which the body is in the fluid medium. So, this has to be determined. Let's say this is h, for example. Now, how will you do calculate this h? See, very simple. Once you know h, you can say pi by 4 d square into h will give you volume of body submerged. But for h, you need to identify, you need to say that now, since body is floating, I can say that weight of the cylinder should be equals to the buoyancy force. Yes or no? Because it is floating always. So, weight of cylinder is what? Mass of cylinder into g should be equals to, what is volume of, buoyancy force? Buoyancy force is the weight of fluid displaced. So, weight of fluid displaced is mass of fluid displaced into g. G will get cancelled. Now, what is mass of cylinder? Can I say it is density of cylinder multiplied by volume of cylinder should be equals to, what is mass of fluid displaced? It is density of fluid into volume of fluid displaced. Now, what is this density of cylinder? This is 600. What is volume of cylinder? Cylinder volume is, let's say this is cross sectional area is capital A and the height is 3 meter. Total height of cylinder is 3 meter. So, I can say capital area into 3. I'm substituting area because I'll just let you know why area will get cancelled. So, I'll not put the values. What is density of fluid? Which is of water, that is 1000. This is fluid is water, so this will be 1000. Into what is volume of fluid displaced? It is the volume of object inside the water. What is the volume? It is pi by 4 d square, that is cross sectional area A into the height h. That is area A into height h. So, area from both sides will get cancelled. So, h is what? H will be equals to 600 into 3 divided by 1000. So, this is coming out to be 1.8 meters. So, once you got h, this is 1.8. So, can you find out volume of body submerged? So, let me just find out volume of body submerged is equals to pi by 4 d square into h, which is pi by 4, d is 4 square into h is 1.8 meters. So, h is 1.8 if you remember from here, 1.8, right? So, what is the answer? Pi into 4 into 1.8, because 1 4 will get cancelled. So, this is 22.62 meter cube. So, you also got volume of body submerged. Now, what are you left with? Let me check. You are left, you got I, you got VBS, you need to find BG. Now, how will you find BG? See, this object has, because it is uniformly dense, so you can say that CG will be at the half of this, So, 3 is the total length. So, I can say that CG will be somewhere over here. So, this is G, and this distance will definitely be how much? This is 3, so this will be 1.5. Also, although it does not look like half, but you imagine that this is the half length, right? 3 half 1.5. Now, what is B? B will be at the center of this portion, center of this much portion which is submerged. So, submerged portion is 1.8 meter, center will be at 0.9 meter. So, somewhere over here, let's say. But this distance is how much? 0.9 meters. So, what is BG? It is 1.5 meter, 1.5 meter minus 0.9. So, BG will be 1.5 minus 0.9, which is 0.6 meter. Now I need to find out the metacentric height. Metacentric height GM is equals to I divided by VBS minus BG. That is, what is I? Just find out I, 12.566. 12.566 divided by, what is VBS? 22.62, and what is BG? 0.6. Let me calculate the answer. 12.566 divided by 22.62 minus 0.6, that is minus 0.044 meters. Let me check the answer. Correct. Which means GM, that is metacentric height, is negative. Metacentric height is negative. It means your center of metacenter is below center of gravity, which means your body is in unstable equilibrium. This floating body is in unstable equilibrium. Now see, try to understand what do you mean by this word. See, equilibrium, that means the body is already in equilibrium at this point of time. The body will definitely float. It does not mean that body will not float, body will sink. It's not like that. Body will float at this position only. But when you say unstable equilibrium, it means that, let us say for an instant, a simple gush of wind interacts the body, or rather if you throw a small stone on a body and say for example a body is disturbed from this particular position, then what will happen is body is not going to come back to its original position, rather body will float but at different orientation now, right? So that's why it is unstable equilibrium. So I hope you got the conceptual clarity on how to solve numericals mainly on determining the metacentric height. Thank you so much. For more such videos you can log into our website clariconcepts.com. We'll see you soon in the next class. Thank you.